We did.
Hey, you recording?
There's Jeffrey. Yeah, I'm going to record. All right, so Jeffrey, what we're going to do is we're just going to all three of us together, okay? So the first one here says that you have a 7.0 Newton weight, right? Raised from the ground at 1.8 meters above the ground. How much work is being done? So what formula did you use? Which one of these did you use?
I used that fourth one looked like.
Okay, so let's look at this. A 7.0 Newton weight, okay? So that is force. Force equals 7.00 newtons, okay? Raised from the ground at 1.8 meters above the ground, that is distance, 1.80 meters. Now remember, if I go too fast, let me know. So on your paper, write F equals 7.00 newtons.
Hold up. F equal
7.00 newtons.
7.00 newtons.
And your distance, which is D, equals 1.80 meters. So based on that information, Jeffrey, which formula am I going to use?
The third one.
Yeah, you're going to use work equals force times distance. So what you're going to do is you're going to take your 7.00 newtons. You're going to multiply that by 1.80 meters. Is your calculators working or not, guys?
No, they won't let us pull them up at the same time on video.
Okay, so if I take 7.00 newtons times 1.8 meters, that's going to give me 12.6 joules. Okay?
You said
so the answer to that question is 12.6 joules.
All right, got it.
Okay, Jeffrey, you good so far?
Yes, ma'am.
Okay, so that's what you have to have for that first one. So can I erase it and go to the next one now? Okay. So what we're going to do is we're going to do this all three of us together, since we ain't got nobody else. So let's look at number 2. Number 2 says an average force of 250 newtons. And remember before, that stands for force, right?
Yes, ma'am.
Okay. Force, and that says effort force. So that's force effort equals 250 newtons is applied to an ideal machine.
So F equals 200 and what?
FE equals 250 newtons.
Okay, got you.
Okay, and it says the effort force moved 800 newtons object a distance of 280 centimeters. What is the mechanical advantage of the machine? So what we're looking for here is we're looking for MA. Okay?
Yeah, we're going to use that fourth one.
So that's MA equals force resistance over force effort. Now, here it tells us that this is an effort force, but this is not telling us about a resistance, is it? Or the effort. So if we look, the force F was 250 newtons, which we talked about just a second ago. So if we look, our force resistance is 800 newtons. So do FR equals 800 newtons.
You said FR equals what?
800 newtons. And our FE, which is our force effort, is going to be equal to 280 centimeters. So our FE is 280 centimeters.
Hey, Miss Simone.
Yes, sir.
I'm finna lose service where I'm at.
Okay, well, this is what I need you to do, Jeffrey. When you get off of here, just come back and check on the video, and I'll have the video up for you, and you can just copy it when you get home.
All right, thank you.
All right, thank you, Jeffrey, for showing up. Is there anything I can do to help you?
I will email you.
You got everything caught up, so you're doing great. Just make sure you keep up with it all next week, okay, baby?
Yes, ma'am.
All right, just check online afterwards for this, okay?
Yes, ma'am.
Okay. All right, so what we're going to do, it says MA equals FR over FE. So that's going to be 800 newtons over 280 centimeters. And so when I got my calculator, which I'm going to get it, and I'm going to take my alpha y equal 800 down 280 over, the answer that I get is 3.200.
You said
So
3.2000.
So it's 3.200 is my answer for this one, for number 2.
All right, got it.
Okay, so let's go ahead and go down to number 3 now.
Mr. Long, I'm about to go get my drink, so hold up.
Okay, that's fine.
Okay, I'm back.
Fantastic. All right, so let's look at number 3. Number 3 says it takes an electrical motor 12 seconds to move 450 Newton load and distance of 25 meters. And it's asking you how much power is developed on the motor. So which one are we going to use for this one?
Hold on, I gotta pull it up in my camera roll because I can't see it on the board. You disappeared it.
Okay.
Because I don't remember. I remember some of them, but I don't remember all of them.
Yes, ma'am. It should be on the sheet on the very top.
Oh, it is?
Yes, ma'am.
We on number 3, right?
Yes, ma'am. We are on number 3.
We're gonna use I think we're gonna use that first one.
So we're going to use P equals, okay? So the options that we have, and we're looking for power, right? So
Jeffrey
P
back.
equals W divided by T, or F D divided by T, okay? So let's look and see what we have.
Jeffrey back, Mr. Long.
Yes, ma'am. So let's look and see what else we have. We have 12 seconds, we have 450 newtons, and we have 25 meters. Okay?
Yes,
So
yes,
what we
ma'am.
have is we have time equals 12 seconds. Okay? It says 450 load. That is my force. And it says 25 minutes. That's my time. So I'm going to go over this one more time. We have, in this question, time is 12 seconds. Force is 450 newtons. And the last one that we need is distance, sorry. So my distance is 25 meters. So based on that information, we're going to use P equals F times D divided by T. So what we're going to do is we're going to plug everything in. So our force is 450 newtons. Our distance is 25 meters. And our time is 12 seconds.
You said what's beside that 450 you just wrote?
450 newtons
Uh-huh.
times 25 meters
Uh-huh.
divided by 12 seconds.
Okay, got it.
Okay? So if I'm going to use my calculator, what I'm going to do is I'm going to do alpha y equal.
Mm-hmm.
I'm going to do 450, close bracket, open bracket, 25, close bracket. I'm going to go down and I'm going to hit 12 and enter. So when I do that, I get 940 is my answer.
So for the number 3 is 940?
Yes, ma'am, it is.
Okay, I got it.
So make sure on yours, the formula that you need for number 3 is P equals FD divided by T.
Oh, I got that.
Okay? And then you got everything else. You good?
Yes, ma'am.
So can we go on to number 5?
Number 4.
Number 4, sorry, can we go on to number 4?
Yes,
Okay.
ma'am.
Scroll down. Number 4 says a machine is required a work input of 180 joules to achieve a work output of 140 joules. What is the efficiency of the machine? So what are we looking for? Efficiency, right?
So we're gonna use that last one.
Yes, then we are. So we're going to do efficiency of work out over work in times 100. That's my formula. Okay?
Okay.
So if I look here, it says my input, my work input is 180 joules,
And the out is the other one.
and my work output is 140 joules. So what I'm going to do is I'm going to take my 140 joules divided by 180 joules multiplied by 100. And when I do that,
Hold up, slow down a little bit, Miss Alone. Slow down a little bit.
yes, ma'am.
So you got one WI equals 180, right?
Yes, ma'am.
And then the WO is
140 joules.
Okay. And
And then what we're going to do is we're taking our work out, dividing by our work in. So we're going to take our 150 joules divided by 180 joules multiplied by 100. And then we're going to get 78%.
I ate the tomatoes for now.
Okay, I got it.
Okay, you got it?
Yes, ma'am.
Okay, so let's go ahead and go to number 5 now.
Were you keeping this, Shirley?
I gave to Mr. Gallagher.
Oh, it's out of date.
That's yeah, I know. No,
Okay.
yeah, no.
So number 5 says a machine lifts 240 kilograms
I found
in a
it.
distance of 100 meters in 45 seconds. How much power is generated by the machine?
Is this too loud?
No, you're good. So which equation are we going to use this time?
We're gonna use.
What are we looking for first?
We're looking for distance, ain't it?
No, ma'am. It says how much power, right, baby?
Oh, so we doing P equals triangle E over T.
Okay? And what's the other ones?
The other one is MAD over WT equals
Yes, ma'am.
FD
What's another one? W over T
and
or
FD.
FD over T. All of those are power, right?
Yes, ma'am.
So these are the possible ones we're going to use for power. So let's look and see what we have. So the first thing we have is 240 kilograms. By 240 kilograms, that is a force, right?
Yes, ma'am.
Okay. 120 meters, what is that?
That's your time, right? No, your
Nope.
distance.
Yes, ma'am, it is my distance. You are exactly right. And you're right, 45 seconds is my time. So I have FD and T. So which one of these four am I going to use?
That last one, FD over T.
Yes, ma'am. So what I'm going to do is I'm going to erase all the other answer choices, the other formula choices that I have. And I'm going to put it over here, rewrite it. And now I'm going to plug my numbers in, okay? So what we have is we have 240 kilograms, right? That's my force.
You brought that out to soccer.
Hold on, Mr. Long.
Mm-hmm.
I'm back.
Okay, so we have our 240 kilograms, that's our force, right?
Yes, ma'am.
Our distance is 120 meters, so we're going to times that by 120 meters.
Yes, ma'am.
And we're going to divide that by our time, which is 45 seconds.
Yes, ma'am.
Okay? So once we do that, when I plug it in my calculator, I get 6,300 watts.
6,000.
300 watts.
And that's the answer, right?
Yes, ma'am, it is.
Okay, I got it.
Now, what I want you to do, baby, when we get off of here, you've got it written down. I want you to open your calculator up and make sure my math's right, okay?
Yes, ma'am.
Okay, so let's go ahead and do number 6. For number 6, it says an adult exerts a force of 25 newtons to pull a child 350 meters across the snow on a sled.
Yes, ma'am.
If the rope that joins the sled has an angle of 30 degrees above the horizontal, how much work is done by pulling the sled? So what are we looking for?
We're looking for the work.
Yes. Now, with our work equations, which are these choices we have right here, so we
Yes,
can either
ma'am.
do work equals force times distance. We can also do force times distance cosine angle, and we can also do mass, gravity times distance.
Mm-hmm.
Now, I know we have an angle, so I know it has to be that one, right?
Yes, ma'am.
So we're going to do FD cosine angle is what we're going to do.
Hey, baby.
All right. So when you see an angle, you know you have to change your calculator to degrees. Okay?
Yes, ma'am.
You want to make sure, write that down for yourself. Make sure to put this in degree mode, because if you don't put it in degree mode, it won't work, will it?
What that you just wrote?
I just wrote down, make sure you put it in degree
Okay.
for your calculator. So, first thing first, what is our force?
Let me go back to the sheet. Our force is 25 newtons.
Yes, ma'am. 25 newtons. Okay. What's our distance?
350 meters.
Yes, ma'am, it is. 350 meters. And then what's our angle?
30.
30. So our formula is going to be 25 newtons times 350 meters cosine, open bracket, 30, close bracket.
Okay. I'm trying to write all that down real quick.
Yes, ma'am. And, I will take my time. I'll wait for you, baby.
And you said cosine 30, right?
Yes, ma'am, I did.
Okay, I got it now.
So in your calculator, you're going to put open bracket 25, close bracket, right?
Mm-hmm.
Open
Yes, ma'am.
bracket 350, close bracket.
Yes,
And then
ma'am.
you're going to use the cosine, and you're going to open, and it'll have an open bracket, right? You're going to do 30 and close your bracket.
Yes, ma'am.
And so the answer to that one I got was 7,600 joules.
7,000.
7,600 joules.
Okay, I got it.
All right, you good?
Yes, ma'am.
All right, let's do number 7 then. And do you see what I do? What I do is when I will go through and read, every time I see a number, I underline it.
Yes,
That
ma'am.
way I'll know I need to look at it. Okay, baby?
Yes, ma'am.
So number 7 says, a mover uses a force parallel to the ramp of 720 newtons to push a 370 kilogram piano on wheels up a ramp onto a stage. The ramp is 8.0 meters long and the stage is 1.5 meters above the floor. Okay? So the
Yes,
first
ma'am.
question asks us, how much work
We doing 7A, right?
on the piano?
Mr. Long,
So
we doing 7A?
we're doing 7A. Yes, ma'am, we are.
Okay.
Okay, so what are we looking for 7A?
We're looking for the work.
Yes, ma'am, we are. So work equals, okay? So let's see what our formula is here. Let's try this one. Work equals force times distance.
Yes, ma'am.
Okay? So what is our force?
720 newtons.
Yes, ma'am. 720 newtons is our force. And what is our distance?
370.
This one's a little tricky. Okay. I agree with you. 720 is my force to push a 370 kilogram piano. 370 is the mass of the piano, isn't it, baby?
Yes, ma'am.
We don't need that. So let's try something else. Where is our distance?
30. No,
How
no.
long is our ramp?
8.0 meters long.
Yes, ma'am. So that's what we're going to do. Think about this. We're looking about the piano, right, baby?
You're gonna fall.
And we're looking at the distance that the piano has to go up. That's why I have 8.0 meters, okay? So what we're going to do is we're going to take our F times our D is what our equation is, isn't it?
Yes, ma'am.
We're going to do 720 newtons, and we're going to multiply that by 8.00 meters.
Uh-huh.
So when I put that in my calculator, I get 5,760 joules.
Okay.
And remember, when we're trying to find work, it has to be in joules.
Yes, ma'am.
Okay? So then we have B now. What is the output of work on the ramp? So what is going on the ramp?
So we would do We would do that 570 something. 5,760 divide times 8.0, right?
Yep, and this is what we're going to do. We're going to use this one right here. Mass times gravity times distance, okay?
Yes, ma'am.
So what is our mass?
So 5,760, right?
That there is the movers, right?
Oh,
We're
okay.
talking about the piano now.
Uh-huh.
Now we're going to use 370, aren't we?
Yes, ma'am.
Okay, so that's 370 kilograms is our mass.
Uh-huh.
What is our distance here?
8.0.
Remember, the 8.0 had to do with the movers, right?
Oh, so it's that 5,000.
It's the 1.50. Yes, ma'am. 1.50 meters.
Uh-huh.
So we have our mass and we have our distance. What is our gravity? What is the normal number for gravity? What have we been using for gravity all this time?
9.8.
Yes, ma'am. 9.81 meters per second squared, correct?
Yes, ma'am.
So what we're going to do is we're going to take our 37 kilograms. We're going to multiply that by our 1.50 meters. And we're going to multiply that by 9.81 meters per second squared.
Uh-huh.
And if we put all that in our calculator, we should get 5,400 joules.
And you got 5,900
5,400.
and 3?
Nope. 5,400 joules.
Okay, got it.
Okay?
Yes,
So what I'm going to do is I'll put this video up for everybody else. I'm going to give you an extra 10 points and Jeffrey an extra 5 because you both came.
Yes, ma'am.
So what I need you to do, if you can for me, baby, go back out, check my math to make sure my math is good.
Yes,
Jeffrey's
ma'am.
still here. Never mind. So Jeffrey gets 10 points too. He's still here. So go ahead and do that, and then take a picture of it in your ISN book, guys, and
Yes,
then
ma'am.
just upload it onto this thing here. And may I tell you, please just keep up with doing your work on Monday and Tuesday like you've been doing. Both
Yes,
of y'all
ma'am.
have done excellent jobs on that. My goal is to have both of y'all having an A next semester, so your grade will be really good when you finish.
Yes, ma'am.
Because y'all both deserve it because y'all working hard. So what I need y'all to do is I just need you to submit that for me sometime before Sunday, and then you're good to go. And I appreciate both of you coming to class today.
Hey,
Yes,
Mr.
ma'am.
Long,
Yes, Jeffrey.
I might need extra help with your work.
What kind of extra help do you need, baby?
This week.
This is what I'm going to do for you, Jeffrey. Are you listening?
Yes, ma'am.
I'm going to put a video up every day for you.
Okay.
So that video will either be from last year or this year's me teaching, and then I'll put it up until you come back, okay? Just so
Yes,
you won't be behind. Does that help?
Yes, ma'am.
All right, I got you.
Yes, ma'am.
All right, guys. Y'all
Yes,
have a good
ma'am.
weekend, and I will see you next week.
Okay.
All right, guys. Thank you for
I'll come back
coming.
the 25th. Yes, ma'am. Bye, Mr. Long.
25th, huh? Well, I
Yes,
love
ma'am.
you both. I'll talk to you later.
All right. Love you too.
Bye-bye, honey.
Bye.